Hi, my name's Michael Alice, and I'm going to go over how to draw contour plots using Masterpiece VR as an example for this. Now here I made a rough sketch of the graph, or the function x squared plus y squared. And I did this by hand. It's not exactly correct, but it's generally in this kind of shape, and I wanted to use this as a reference for that. So when you have it like this, it's the function in terms of x and y, and when we make a contour plot, it should start off at the origin, which should be 0, and as it increases, as you can see, it's going to the radius of the circle is going to increase gradually. Now, if we wanted to, we could also take the function and rewrite it in terms of another one of the axes, like y, and make it a function of x and z. And then the graph would start off at the origin, and as you can see, this shape would increase in size in the z direction, or increase at the starting point. So when we have a function in terms of x squared plus y squared, it's actually really simple to do this kind of thing, because x squared plus y squared is the shape of a circle, and there's other shapes that we're familiar with, like ellipses, that are easy to graph that way. So we know that f of x and y is also known as z, but we can have that in terms of c. Now when we have c, we can write terms of c, so let's say c equals 0, and then we know that 0 is equal to x squared plus y squared. Now all that means is that the radius of the circle, x squared plus y squared, is 0. That's pretty simple enough to graph. Right there. Don't know if you could see that, but hopefully that's clear enough. So let's say c equals 1 this time. 1 would equal x squared plus y squared. Again, that's pretty easy. The radius of 1 in each direction. And so you get the general idea. And that's pretty easy, but like I said, let's try it from a different angle. Let's rewrite this so that you can graph the contour plot in the xz plane in terms of y. So I went ahead and rewritten this here, where z is equal to x squared plus y squared. Rewrote it as y squared equals z minus x squared. And so y equals the square root of z minus x squared. So we can have this time y is equal to c. So when c is equal to 0, 0 is equal to the square root of z minus x squared. So square root of 0 is 0. So we have z is equal to x squared. Now, what do we do from here? Well, you can plug in different values of x to get your z value from that. You could try doing something weird with this, but that would just take too long, because you'd have to plug in values for z and x. It's much easier to rewrite it in this form, where it's just one variable on one side in terms of another variable. Because all you need to do is plug in one value for this variable in order to get your z variables. So let's say x is equal to 0. Well then, z would be 0. That's the origin. That's pretty easy. Let's say x is equal to 1. Well then, z would equal 1. Oh, that was messy. So, that's true. What else? Let's say if x is equal to -1, then that's also true. It would result in z equals 1, because 1 squared is going to be positive. Now, one thing you have to keep in mind is that you have to keep in mind the domain of the original function. If z equals x squared plus y squared, you have to make sure that the result of your calculation makes sense in the terms of your original function. As you can see in this graph, this function never goes into the negative z values, and you want to make sure with that with whatever formula you get, like with ln's, or if it's a fraction, you want to make sure that your function is never outside of the domain of your original function. Your calculation, yeah, so that's what I meant. But so let's go on. Let's say x equals 2. What do you get? That's 4. Z equals 4. Again, this is another rather simple, straightforward function, even in this way. But this is way it's more involved in calculating rather than just automatically knowing that's a circle. It's the same for at x equals -2. So we know those so far for the first contour plot. Oh yeah, I forgot to mention earlier, when you write a contour plot, you want to make a line from it and labeling it, saying that c is equal to 0 for the origin. Right, I didn't quite do that. That's the other way around. Let me just shift these around. So yeah. I messed it up again. Alright, so this one is supposed to be C0, and this one is supposed to be C1. They're two different lengths. Okay. So the C equals 0 is supposed to be the origin. And so this first radius is C equals 1. Likewise over here, we have x equals 1, z equals 1. The same for on the negative side. X equals 2, z equals 4. And same on the negative side. Say x equals 3. Then z, we could just write plus and negative here. Then z will equal 9. So 3 and 9. 3 and 9. And as you can see, if you had a steady hand, that it should be in this shape here. And that's quite similar to what we get over here. As you can see, it's in generally that shape. So, yeah, so that's c equals 0 for the function in terms of y, the graph of the x z plane. So that's that one. Let's go over here and write, it can still be over here. Let's do c equals 1. That was just c equals 0. So 1 is equal to the square root of z minus x squared. Now it's very similar to what we had last time, but it's going to be 1 plus x squared equals z. And the only difference really is when you, as you can see, when you plug in, let's say x equals 0. When x equals 0, then z will equal 1. So what happens is this thing went up to 0, 1. What happens when x is equal to 1? Well, then z is going to equal 2. That's going to be plus and minus 1. Because when it's a negative 1 that you plug in there, it's still going to become positive. So 1 plus 1 is 2. So it's going to be right there and right there. Yep. When x is equal to 2 plus or minus, then z is going to equal 5. Two and 5. 2 and 5. Then when x is equal to positive or negative 3, z is going to end up equaling 10. So it's a little bit above this graph, what I drew. So 3 and 10. 3 and 10. So it's going to look generally very similar to the last graph, but shifted up 1. And it's going to continue to shift up gradually as this shape continues on into this direction, I'm pretty sure. Because this, no, wait. So there's x, right? What happened to the graph line? Anyways. Oh, there it is. So yeah, there's my x-axis. So, as you can see, the z is there, the x is there. So it'd be shifting up in the y direction. And as you can see, as it continues to go in the y direction, the shape is increasingly going up along it. So, last thing to do is to label it c equals 1. I'm pretty sure it's best to have c equals 0 at the very top of the list, and then have it, go cascade down in terms of positive values. But yeah, that's generally it. I hope you enjoyed this. If there's anything wrong, I'd like to know. And yeah, thank you very much. This has been Michael Alice, and yeah, hope you have a good day.